Welcome back. In the previous episode, we deployed our very first AWS infrastructure using Terraform. We learned how to initialize a project, create resources, update them, and destroy them. But today, we're going to answer an important question. How does Terraform know the order in which resources should be created? How does it know that one resource depends on another? And when do we need to tell Terraform the correct order ourselves? That's exactly what we'll learn in this episode. We'll build multiple AWS resources, connect them together, understand how Terraform automatically detects dependencies, and finally, learn when to use depends_on. By the end of this episode, you'll understand one of the most important concepts in Terraform, the dependency graph. Let's get started. Before we jump into Visual Studio Code, let's take a quick look at today's roadmap. First, we'll understand the structure of a Terraform resource. Every resource follows the same pattern: a resource block, a resource type, a local name, and its arguments. Next, we'll build connected resources by adding a security group to the EC2 instance we created in the previous episode. Then we'll see how resources communicate using references, how Terraform automatically detects dependencies, and when we need to use depends_on. Finally, we'll run Terraform plan and Terraform apply to see the dependency graph in action and understand how Terraform decides the correct creation order. By the end of this episode, you'll understand not only how to create resources, but also how Terraform knows how those resources relate to each other. Let's open Visual Studio Code and get started. We're back in the project we built in the previous episode. As you can see, the project is exactly where we left it. For security reasons, I already removed the AWS resources we created in the last chapter. I also deleted the IAM access key and secret access key that we used for the demo. So before we continue, we'll create a new set of credentials. This is good practice because you should never reuse demo credentials longer than necessary. Later in this course, we'll learn how to manage IAM resources with Terraform as well. But for now, we'll create a new access key manually, update our provider configuration, and continue building on the project we already have. Oops, I always forget this confirmation checkbox. There we go. Now that the new access key has been created, let's copy both credentials and bring them back into Visual Studio Code so we can continue with the lab. We created a new access key, so let's initialize the project again. Terraform will verify the provider and make sure everything is ready. The infrastructure from the previous episode no longer exists because I removed it after recording. Since our Terraform configuration is still here, we can recreate it with a single command. Great. We're back exactly where we finished the previous episode. Now let's continue building on top of this infrastructure. Our EC2 instance is back, and now we're ready to continue building on top of it. In this episode, we're going to add a new AWS resource, a security group. A security group acts as a virtual firewall for our EC2 instance. It controls which network traffic is allowed in and out of the instance. As always, let's start with the official Terraform documentation. We'll search for AWS security group. Just like we did in the previous episode, we'll use the official documentation as our starting point. We'll copy the example, understand how it works, and then adapt it to our own project. I'll copy this resource into our project, and then we'll simplify it so we understand exactly what each argument does. This example is much larger than what we need today. Instead of guessing which parts we should keep, let's use the AI assistant built into the browser to help us understand the example. Great. This is the security group itself. It defines the firewall that will attach to our EC2 instance, so we'll definitely keep this resource. This resource defines an inbound rule. In this example, it allows HTTPS traffic on port 443. We'll keep this idea, but we'll modify it for our own lab. Since we're keeping this lab as simple as possible, we don't need IPv6 today. I'll remove this resource. This resource controls outbound traffic. We'll keep this one because allowing outbound traffic is very common. Perfect. We started with a complete example from the official documentation. We used AI to understand what each resource does, and now we've simplified it to include only what we need for today's lab. Wait, these are now 3 independent resources? How does Terraform know which one should be created first? That's a great question, but before we run Terraform plan, let's take a closer look at the resources we just copied from the official documentation. Remember, we copied the complete example. Now we need to review it and adapt it to the requirements of today's lab. The first thing I notice is this line. We're referencing a VPC called AWS_VPC.main, but if we look at our project, we don't have a VPC resource. That's because this example assumes you're building your own VPC with Terraform. We haven't learned that yet, so let's modify this resource to work with the infrastructure we already have. Before we update the Terraform configuration, we need 2 values from AWS, the VPC ID and its CIDR block. Let's switch over to the AWS console. A VPC, or Virtual Private Cloud, is your own private network inside AWS. It's where you'll deploy resources like EC2 instances, databases, load balancers, and many other AWS services. An AWS account can have multiple VPCs in the same region, which is very common in production environments. If this is a new AWS account, you'll usually see something called the default VPC. AWS creates this VPC automatically in every region, so you can start launching resources without building your own network first. But for today's lab, we'll simply use the default VPC that AWS has already created for us. Now, let's customize this resource for our own project. All change is the local name. Instead of allow_TLS, I'll rename it to something more meaningful for this lab. I'll also update the security group name so it matches our project. The description looks good, so I'll keep it. We already replaced the VPC ID with our default VPC. Finally, I'll update the tags. We already talked about tags in the previous episode, so I'll simply rename them to match this project. Great. Our security group resource now follows the same naming convention as the rest of our Terraform project. This is where the interesting part begins. Notice that we're not typing the ID of the security group manually. Instead, we're referencing the security group resource we created just a moment ago. Terraform will automatically retrieve its ID after it's created and use it here. This is called a resource reference, and it's one of the most powerful features of Terraform. As you'll see in a moment, this simple reference is enough for Terraform to understand that the security group must be created before this ingress rule. Let's quickly review the rest of the configuration. The CIDR block defines which network is allowed to reach this security group. In this case, we're using the CIDR block of our default VPC. Next, from _port and to _port, define the port range. Since both values are 443, we're allowing traffic only on port 443. Finally, IP_protocol equals TCP tells AWS that this rule applies to the TCP protocol, which is the protocol used by HTTPS. We'll learn much more about networking and security groups later in the course. For now, the important concept is understanding how this resource references our security group and becomes part of the dependency graph. I'll also rename this resource to match our naming convention. Great. Finally, we have our last resource, the egress rule. Before we continue, I'll also rename this resource. Just like the previous resource, this one defines an egress rule, which controls outbound traffic. Here, 0.0.0.0/0 means traffic is allowed to any IPv4 destination. And IP_protocol equals -1 means all protocols are allowed. Just like the ingress rule, this resource also references our security group using one more thing worth noticing. As soon as I renamed the security group resource, VS Code highlighted this reference and even suggested the new name. That's because this resource is pointing to another resource in our Terraform configuration. These editor hints are very helpful, especially as your projects grow. I'll simply accept the suggestion. And now this reference points to the correct security group again. This is exactly the kind of reference Terraform uses to connect resources together. And in just a moment, we'll see how Terraform uses these references to automatically determine the correct creation order. So now our configuration contains 3 connected resources: the security group, the ingress rule, and the egress rule. Now comes the interesting part. How does Terraform know which one should be created first? Let's run Terraform plan and find out. Just like in the previous episode, Terraform analyzes our configuration and tells us what it's going to do before making any changes. In this case, it's going to create 3 new resources. First, the security group, then the egress rule, and finally, the ingress rule. 3 to add, 0 to change, and 0 to destroy. But here's the interesting part. We never told Terraform to create the security group first. We never wrote depends_on. So, how did Terraform figure out the correct creation order? How does it actually represent those relationships internally? Terraform can generate something called a dependency graph. This is the dependency graph in text format. It's not very easy to read. It requires GraphViz to visualize it, so I already have it installed on my machine. Here we can clearly see the security group at the center, and both the ingress and egress rules depend on it. Terraform built this graph automatically just from the references we wrote in the configuration. Now, let's apply the configuration and verify that Terraform creates the resources in the correct order. Notice what's happening. Terraform is creating the security group first. One thing I want you to notice is that the order of the resources in our Terraform file doesn't matter. We could move these resources around, place the ingress rule first, or even put the security group at the bottom of the file. Terraform is smart enough to analyze the relationships between resources before creating anything. It doesn't rely on the order we write the code. Instead, it builds an internal dependency graph based on the resource references. That's why the security group was created first, and only after it existed did Terraform create the ingress and egress rules. This is called an implicit dependency. We never wrote depends_ on anywhere in our configuration. Terraform automatically determined the correct creation order simply because these resources reference a security group. If we look at our EC2 instance, nothing has changed yet. Notice something interesting. Our instance is still using the default security group. The new security group exists, but it hasn't been attached to the instance yet. So the question is, how do we tell Terraform to attach our new security group to this EC2 instance? Let's go back to Visual Studio Code and make that connection. This is where another Terraform reference comes into play. To attach a security group to our EC2 instance, we only need to add one argument to the instance resource. This argument expects a list of security group IDs that should be attached to the instance. And once again, notice that we're not typing the actual security group ID. Instead, we're referencing the security group resource we created earlier. Terraform will automatically resolve the real ID during deployment. Now let's run Terraform apply one more time and see how Terraform plans to update the instance. Perfect update in place. Terraform has detected that only one attribute needs to change. Here we can clearly see what's happening. Terraform will remove the default security group and attach the new security group we created with Terraform. The summary confirms it. 0 to add, 1 to change, and 0 to destroy. Only our EC2 instance will be updated. Great. The update completed successfully. Now, let's go back to the AWS console and verify that our EC2 instance is using the new security group. Oops, it looks like the AWS console hasn't refreshed yet. This happens sometimes. Instead of assuming something went wrong, let's verify it using the AWS CLI. And since one of the goals of this course is learning how to use AI effectively as a DevOps engineer, let's ask ChatGPT to help us generate the command. This is exactly what we need. We didn't have to remember the command from memory. AI generated it for us, and now it's our job as engineers to understand what it does and validate the result. Perfect. The AWS CLI confirms that our new security group is already attached to the instance. The console was simply taking a little longer to refresh. This is a good example of why experienced DevOps engineers always validate changes using multiple tools instead of relying only on the web console. At this point, we've seen that Terraform automatically detected all the dependencies in our project. We never use depends_on. That's because Terraform was able to understand the relationships from the resource references. So when do we actually use depends_on? Sometimes two resources don't reference each other directly, but one still needs to wait for the other. In those situations, we can use depends_on to create an explicit dependency. This should be the exception, not the rule. If Terraform can determine the dependency automatically through references, that's the approach you should prefer. But I think this is much easier to understand by looking at the code. So let's do something that's already part of our learning methodology. Use AI as a tool to help us. I'll ask it to generate a very simple example with two Terraform resources that use depends_on. Then we'll copy it into our project and walk through exactly what's happening. I already have a prompt prepared, so let's send it and see what AI comes up with. Then we'll review the example together and make sure it actually follows Terraform best practices before using it. AI generated a very simple example. Here we have two completely independent resources. First, Terraform creates an S3 bucket. Then it creates an SSM parameter. Notice that the SSM parameter doesn't reference the bucket anywhere. There's no bucket ID, no ARN, and no bucket name being used. So Terraform has no way to infer that one depends on the other. By adding depends_on, we're explicitly telling Terraform, don't create this resource until the S3 bucket has been created. In our lab today, we didn't need depends_on because Terraform could infer the dependencies automatically from the resource references. That's why implicit dependencies should always be your first choice, and depends_on should only be used when Terraform cannot determine the correct order by itself. Let's quickly validate the example. Notice that Terraform accepts the configuration even though the SSM parameter doesn't reference the S3 bucket directly. Depends_on tells Terraform that the bucket must be created first. The plan shows exactly what we expected. Terraform wants to create two resources, the S3 bucket and the SSM parameter. The plan does not display the creation order directly, but Terraform has added an explicit dependency because of depends_on. For this demonstration, the plan is enough. We can now remove these two test resources from the configuration. Now the plan is clean again, and our temporary resources are no longer part of the configuration. Before we wrap up, let's not forget one important best practice. Whenever you're done with a lab, remember to destroy the resources you created so you don't leave unnecessary AWS resources running and generating costs. And since we manually created an IAM user for today's demo, let's also go back to the AWS console and delete that user. Cleaning up your environment is just as important as deploying it. And that's it for this episode. Today, we learned how Terraform manages multiple resources and how it determines the correct creation order using both implicit and explicit dependencies. In the next episode, we'll take the next big step by replacing hard-coded values with variables and outputs. You'll learn how to write reusable Terraform configurations that can be used across different environments without changing the code. Thanks for watching, and I'll see you in the next episode.